This is our vacuum cleaner robot. It has 3 ultrasonic sensors for detecting the obstacle. On the downside, bot has a IR module for detecting the floor and 2 entity motors for movement. In the center, I placed the vacuum cleaner. Also, bot has a caster wheel for balance. We can open the cap of vacuum cleaner by pressing the cap. Now let's see the working of the robot. For cleaning test, first I disperse some thermocol pieces. And you can see our bot sucked all the thermocol pieces. Now you can see how this robot avoids edges. Now let's open the cap and you can see the dust particles. All details about this project are available in the website, link is in the description.
Hello all, welcome to another video of Circuit Digest. In this video I'll show you the working of this thermal gun. So the thermal gun was built using the MLX 90614 contactless thermometer, which is this one, and it was interfaced with an Arduino Pro Mini to an OLED display, and we have 3D printed this enclosure. So as you can see, we have the sensor over here and a laser diode on top of it to point at the object whose temperature we are measuring, and it is connected to an Arduino Pro Mini and then to an OLED display. And the power to this Arduino board is provided by this 9-volt battery. So the raw pin and the ground pin comes out through this hole over here, and it goes through this push button, and then it is powered by this 9-volt battery which fits inside the handle of the gun. So the complete circuit diagram, the code for the Arduino board, as well as the 3D design of this enclosure can be found at the link given in the description of this video. So here this project is ready to work. If you press the button, you can see the circuit getting triggered. So whenever I press the button, the circuit closes, the connection for the Arduino, and it gets powered. So let's see how it works. Let me point randomly on the sheet over here. If I press the button, you can see the OLED displaying some message. And right now it shows 31.6 degrees Celsius, which is the atmospheric temperature as well as the temperature of this table. You can see the laser diode. So this laser diode comes in very handy, especially if you're measuring the temperature of a particular component. So if you want to point it at a sensor, you can point it to a sensor and read the temperature value. So right now the board is not powered, so all the resistors are in the same temperature. But if a resistor is heating up, or if a particular component, say this IC or this voltage regulator, is heating up, you can use this gun to easily identify the temperature of a particular component or any object for that matter. So to show you a difference, I have a bottle of water over here, which is not that cold, but it is cold enough to show you a difference. So if we measure the temperature of this water bottle, so it shows 29.7, which is relatively colder than the sheet that's over here. So if I move it away from the bottle, you can see that the temperature is 31.1. As I bring it towards a colder object, you can see the temperature going down to 29 or 30, and as I move away you can see the temperature increasing to 31. So let's try to test this gun on some other object. Okay, now we are outside and the temperature is pretty high over here. So let's try to measure the temperature of this metal handle. I'm pointing the gun at it, and as you can see it's pretty much hot. It's around 40 degrees Celsius. So that's it guys, this pretty much shows that the gun is working properly. You can test it out, and if you have any comments you can leave them at the link that can be found at the description of this video. Thanks for watching. Hello guys, welcome to another video of Circuit Digest. In this video I'll show you the working of the blind stick project. So this blind stick project is made out of Arduino. As you can see, we have the ultrasonic sensor over here and the LDR sensor over here, and we also have another small circuitry, which is this one, the IR remote, and we have the IR receiver over here. So whenever the user presses the button from this transmitter, the receiver will receive the signal and the Arduino will react to it. So let me plug in the receiver. Okay, now everything is in place. The ultrasonic sensor will measure the distance. The LDR will check for the intensity of light around the blind person. The RF transmitter will receive the RF signal from the blind person's remote, and we have a buzzer which will overall indicate what is the status of objects around that blind person. So as you can see, this transmitter is very small. The blind man can easily carry it in his pocket, and if he loses his stick or if he wants to know where his stick is, he can just press this button and this buzzer will start beeping and he can be guided to the stick. So to demonstrate the project, I'm using two 9-volt batteries to power both the transmitter and the receiver section. So let me power the complete setup using my laptop. So I can also show you the serial monitor reading. So let's go ahead and check the working of this project. I programmed the ultrasonic sensor to sense from a distance of 50 centimeter. So let me go ahead and place my hand over here. As I bring my hand closer, the beep's frequency will increase. And you can also see in the serial monitor that there has been an object detected at some particular distance, and you can also check the LDR by blocking the light source to the LDR, and you will see that a low light alert has been triggered. So similarly, you can also check for high light. I'll just move this towards my window, and this is the alert for bright light. As you can see, the serial monitor says that it's a bright light and you can hear this tone. So the blind man can identify if he is in a dark room or in a bright room. Of course, you can program it to modify the intensity of the light and change the beep sound. Now let us see how the remote control works. We have the remote control, which is nothing but an RF transmitter along with the button. So whenever I press this button, the Arduino will be able to receive it using this receiver, and you can hear a beep. So let me go ahead and press it. You can see that a remote pressed indication is being displayed on the serial monitor, and that sound will be received. So the blind man can identify where his stick is by pressing this remote on the transmitter. So just press it and you can hear the sound. Let's try it again. So this is how the remote works. Now let's power the complete setup using a 9-volt battery and hook it up to a small stick and see if it could actually work on a 9-volt battery. Assemble the complete project over a small stick, which I assume it to be a blind stick, but you can actually use a real blind stick. And the complete board is now powered with a 9-volt battery, which is also stuck to the stick. Now let me turn this towards the wall over there and let's see if it's working in the same way. And you can see it is buzzing to indicate that there is an object in front of it, and as I come back, the buzzing stops. Now let us go forward, and the closer we get, the harder the buzzer sound will become. So this is it guys, this is how the project works. As usual, you can find the complete schematics and the code for this project in the link given in the description of this video. Thanks for watching. Hello guys, welcome to another video of Circuit Digest. In this video, I'll show you the working of Arduino based calculator. So in this project, we have used a keypad, which is a 4x4 keypad, as an input device and an LCD as an output device. So I have used a breadboard to connect the LCD to Arduino, and I have directly mounted the keypad to the female pins of Arduino. The complete circuit diagram and the code for this project can be found at the link given in the description of this video. In this video, I'll just explain you the working of the project. So follow the circuit diagram there and make the connections as shown in the circuit diagram. It would look simple like this. You can either use a perf board or you can use your own ways to connect the circuit, but this is how I have done it. Now let me go ahead and power the circuit using a 9-volt battery. So as soon as I power, it shows some introductory message and we get the screen where the calculation happens. Now let me use the keypad and perform a calculation, a simple calculation. Here we have the letters A, B, C, D and star and hash, but I have repurposed the use of this button. For example, A will be addition, B will be subtraction, C will be multiplication and D will be division, and hash will be the equal to symbol and star is to clear the values. Now let me go ahead and show you how it works. 1 plus 1 is equal to 2. So just a simple thing to show you that it works. So I have zoomed into the result. As you can see, it's displaying that 1 plus 1 is equal to 2. Sorry for the shake. Now let us try some other values. To clear it, I have to press the star. So it's cleared now. Now let's do some other. 45 multiplied with 88. So you can see that whatever I type is being displayed on the second row and the actual result displays in the first row. So let me press the equal to symbol. So we have 45 into 88 is equal to 3960. You can do any calculations, but after every calculation you have to press the star button to clear it so that everything gets 0. Now let's do a bigger number, 856. You can see the one that I'm typing appears here, and as soon as I perform the operator, for example, let me multiply here 856 into 999. So you can see 999 here, and if I press equal to, you get the result. So you can do any operations like addition, subtraction, multiplication and division. With a few tweaks in the program, you can also drive for decimal values, but for now we are not using decimal values in this project. So this is how the project works, guys. So as usual, the code for this and the circuit diagram for this, along with a detailed explanation on how to connect and how the code works, everything can be found at the link given in the description of this video. Thanks for watching.
Hello everyone, Devasis here. Welcome to another interesting video tutorial on Circuit Digest. In this tutorial, we will learn how to make a scrolling test LED notice board using Arduino Uno and a P10 LED display module. And this LED display module is a LED matrix display module, which is also called as P10 LED display module. It has a 32 cross 16 LED pixel resolution because it has 32 LEDs in a row and 16 LEDs in a column. Okay, so this is a single unit display module, but if we want to make a larger display module, then we can use multiple pieces of this module, and it is very easy to connect. Okay, let us have a look. This module has 3 terminals. 2 terminals are for data. This is for data input and this is for data output. And in the data input side, I have connected it to a Arduino Uno, so that Arduino Uno, the data which we want to display on this module can be given from the Arduino Uno by using our program. Then if we want to give a extension of this display module, then we can connect the output side to the input side of the another LED board. Okay, and this is for power supply. Then power supply should be given individually to all the boards, all the modules. It requires 5 volt DC power supply. In my case, I have connected the module to the 5 volt 3 ampere SMPS. Okay, and the connection diagram of the P10 LED notice board with the Arduino Uno is given in the description link, and also the programming of Arduino Uno has been explained in the link in the description box. Okay, so let us have a demonstration of this project.
Get